Hello everyone. In this video we'll continue learning about expected value, and in particular we will learn a formula which will make our life easy when it comes to calculating the expected value of a binomial random variable. Well, let me quickly recall that if x1, x2 up to xn are values of a discrete random variable x, and f is PDF of x, then the expected value of x, or just mu, is going to be given by this. So you multiply the first value to the PDF value of that, the second value to the PDF of that, and up to xn, f of xn. That number is called the expected value. Well, let's see what is the example here. Expected value, a coin is tossed 3 times. Find the expected value of the number of times that head comes up. So when you're working with the number of heads, remember that, well, this can be either 0 heads, 1, 2, or at most 3. And the probability that we get a 0 head is, well, you just simply calculate that one, but that's just easy number because now you can calculate actually more than one way this one. What at the end you will get is, this is 1 over 8, this is 3 over 8, this is 3 over 8, and this is 1 over 8. Okay, then that means that the number of the expected value of a number of heads is equal to 0 times 1 over 8, 1 times 3 over 8, 2 times 3 over 8. Note that I'm multiplying this row to the corresponding entry in the second column, and 3 times 1 over 8. So you add these guys, all of them have common denominator 8. You have 3, 6, and 3. This is 12 over 8. And if you simplify that, you see that it is 3 over 2. Or in average, out of 3 tosses, there will be half of that, which is 1 over half heads will come up in average. Half of the tosses will come up to be head, which is 2 over 2 in this case. Well, you see that the random variable that counts the number of heads is a binomial random variable. Note that the above random variable is binomial random variable. The number of trials is 3 and the success rate is half. While people called mathematicians, they have done a good job on this, and they have proved that theorem that expected value of binomial random variable by n and p, n trials and rate of success p, this is a random variable. Okay, so each time you can form this table and calculate it, but when it comes to the binomial random variables, there is a simple formula for this. This is n times p. Okay, so but using that formula there, you see that E of B 3.5 is going to be 3 times half, which is 3 over 2. So this formula, at least in this example, matches. But this is theorem. It means that it's always going to be true when you're working with binomial random variables. Okay? So when if your question is giving you a random variable and you figure out that random variable is a binomial random variable, you can just go ahead and use this formula. You don't need to draw the table and do all those works. For example, what is the expected value of the number of 6 that comes up when we roll a die 4 times? You see that number of 6s in 4 die rolls, this is binomial random variable. How many times we are repeating the experiment, or the number of trials, is 4. What is the probability that you get 6 when you roll a die? It's 1 over 6. Then the expected value, so E of B for 1 over 6, which is basically what this guy is asking, expected value of number of 6 that comes up in 4 rows. This is going to be 4 times 1 over 6. This is just 4 over 6. Wow. This is 2 over 3. So you don't need to form that table, which will have 5 the possible values and then multiply and get all those things done. This is the formula you can use because this is a binomial random variable. Okay, so you have to know this formula for binomial random variables. That's it.